The look of the modern world took shape in the early 1900s. The use of metal revolutionized building and brought us the skyscraper. We have been part of that revolution from the start. Today, we offer smart, easy-to-use machines for sheet metal processing that save material, time, and the environment. This is how we help builders and industries around the globe to shape tomorrow's world, like we have been doing since 1907. Shaping tomorrow's world.
Hi, I'm Shannon, Regional Sales Manager of the Midwest. I'm here with Yassine, Application Manager. Thanks for joining us live today on our YouTube channel. We get the opportunity to work with an array of, architectural metal shops to pole barns to metal buildings to residential, commercial roofers. Such an array of sectors in himself, right?
Yeah.
And what I would like to do today is kind of treat this as a production conversation.
Yeah.
So that we can understand the flow from the Rapido shear all the way to the folder itself and to maximize efficiency.
Yeah, so today actually we have the shear here, the Rapido 32, and then we will show like exactly like you said, we will show the workflow from the start to the beginning. Starting from having the blank, cutting it, dropping it on the wagon, transporting it, and then we're gonna fold it on our machine FS32 XSPACE, and we're gonna show what's the advantage of having this machine as a shear, also including that folder as one of your folder to increase production.
Absolutely. And surprisingly, throughout all of these sectors, we have common problems, right?
Yeah.
And one of the most important ones is what? Skilled operators.
Yes, sir.
Right?
Yeah.
I mean, Joe has been employed for 25, 30 years at commercial roofing company, and he's getting soon to retirement. And then we're like, oh no, what's going to happen when he leaves us, right?
Yeah.
Another one is material. Some of the material that we have today is copper. Copper is not cheap in today's world.
It's really expensive.
And there's no cut around that.
Yeah.
Right? Another one is details. Details really matter in today's world.
Yes, that's definitely true. Having just a really a small detail that makes the part a little bit complex, actually that will put you apart from other
shops down the road.
Exactly. And just a small detail can increase your presence in the market, can get you into the light to people actually will prefer to get your product instead of other company.
To kind of piggyback off of that, common issue is timelines.
Yeah.
Timelines. I mean, I live in the Midwest, right?
Yeah.
I live in Fort Wayne, Indiana. And I think the snow is melted now. It's been supposed to have nice weather this week, but throughout the last month and a half, 2 months, we have had snow. And what that does for us, or not us personally, but the shops out there, is that we're not able to schedule job installation. Yeah. And so it kind of sets us back, right? And so what we would like to do to illustrate all of this is we're going to go through, demonstrate on the whiteboard here is let's diagnose a workflow, right? So let's just say stage one is a forklift is going to have to get the material that is needed for this job. So material is picked. Right? Number two is that material has to be staged next to what? The shear. Hope you guys can read my handwriting, sorry. Number 3 is once that material is staged, it's going to be cut down by the shear. After that, once we have our blanks, number 4 is we're going to have to take those blanks to be staged for the folder. After those blanks are then folded, after that is we have to wrap or plasti wrap those blanks to get ready for customer pickup or delivery to the end destination, which the job is being installed.
Yeah.
Right. So again, what we'd like to do is show this workflow to make up for time, be efficient, and improve your quality.
Exactly, like actually increasing or any stage there, like optimizing any stage there will increase the production of the customer, and also like will affect how the end user, the perspective of the end user of that specific company. Mm-hmm. So yeah. That's a really a great workflow.
Now, I go into a lot of shops, right?
Yeah.
I'm sure you have to be an applications manager, or we always invite people down to our headquarters. Yassine and I are down at Peachtree City, just outside of Atlanta. Our headquarters in the United States is located here. We always invite you down here to physically see how these machines work. And I came up with this idea a few months ago of how important it is for our customers to kind of take a look at these machines, right? When customers are purchasing a shear and it's close to $50,000, or a basic F32 folder that is close to $100,000, that's a lot of money.
Yeah,
a lot of money.
Yeah.
Or to go to a fully automated double folder where you have your side loading, you have your unloader, and that machine is...
You need to see it.
You got to see it, right? It's really, really cool.
Exactly. Seeing is believing.
And the most important aspect to that is application.
Yes, sir.
Because let's just say that you're a customer of mine and you have my number. Someone down the street has a CIDAN folder. Yeah. And you're like, oh, he just got that. He's up and running. He's doing really well. Or it's news on the street, right? You call me and you say, hey, I need a folder. Well, I could sell you any machine that you tell me that you find on our website, right? But that's not how we work.
No.
We try to be a consultant to your needs, your application, your material that you're using, and then also of what specific parts that you're making so that we are fitting you right with the right machine. Yeah,
that's exactly true. So basically what we do is like we're getting generally the drawings from the customer, from the prospect. We get in the drawing and we analyze those drawings. We check the feasibility, which machine is more optimal to the customer. Like you said, exactly like you said, we just don't want to sell him any machine. We want to sell him, or sell him the machine that he actually needs. Because at the end of the day, we want a partnership. We don't want just to sell just one machine and that's it. We want it for the lifetime of that company. So we want to suggest the most optimal machine for their application. So that's what we do.
Let's take a look at the shear.
Yeah, of course. Here, so we have, like we said earlier, we have the Rapido 32. So this machine is 13 gauge mild steel, an 8 aluminum, and 12 gauge stainless. This is really fast shear. As you can see here, I will just cut it in a continuous mode right now. It's on. You can see how really fast it is. We're talking about 35 cut in a minute. I will disable the continuous mode right now here. So to just like give you a really fast workaround of this machine. So the first thing you need to do, of course, is like you put the baggage, the dimension that you want to cut. They say you want to cut 5 inches, you put 5 and then hit check. The baggage move into position. You can see how precise it goes there, right? Let me do it again. So we're talking about baggage that's really precise, and you put your blank right here in this space. You push it until it's hitting the baggage stop. You can always square it to these sides here, and then you have 2 options. Either push this button to cut it, or you can always like use the pedal here. Whenever you push the pedal, you cut your blank. Another thing, guys, I want to show you, if you come to it this way, please, you can see that this machine have a support here. So this support work in pneumatic. If whenever I have, let's say, a long blank, I'm cutting like 25 or 30 inches, I want to support it. So that's why we have here this support. Let's say you're cutting a small piece. At that point there, you not really need the support. You can always disable it or put it down. So if you go to the menu here and you put support down, it's actually going down, right? You can have 3 options, means like you can always put it down, or always put it up, or put it in a auto mode. In the auto mode, it depends on the dimension of the baggage. So if you send in it really, really far to the maximum, or a bigger dimension, your support gonna rise up. So that was just so quick. Touch the screen and you change the behavior of the machine. It depends on your application, it depends on your needs. After the cut, of course, you get the material drops to the front, and you have here this wagon that will have the material. Then you can transport it wherever you want.
So this material wagon, it's very user-friendly. What the development team and the design team, what we've done here is, why is the handle in the middle? A lot of the competitors, the material will drop down and it's fixed within the machine itself. So it's necessarily a shelf, and then it's stopped. And then that material has to be picked up and then moved to another material wagon. So what we've done is we put the arm, the controller here, so I can maneuver it around wherever I need to go. And then also what is really nice is the material wagon can be picked up with a forklift.
Yep, definitely. Like somebody gonna say, oh, you have a sport here. This one is movable actually, so you can take it out and then you can pick it up with a forklift. So
let's talk about what's the depth of that gauge?
The depth, the maximum depth is 39 inch. To be more accurate, I will just send it to the max there. Is 39 point, as you can see here, 37 inches. So this is the maximum depth of our chair here. Another thing I wanted to talk about is the cut list. Let's say, because we just showed how easy and how quick we can actually like cut blank. Like you want just like, I don't know, a 5-inch blank, you put it there, you put 5-inch and you make sure it's square, of course, and then you hit the cut here or the pill, right? Now let's say if you have a cut list. If you have a cut list, you put here and you put the whole list here, right? And you can save it. You can save it. I already have this. Let's create a new one. So to create a new one, you hit this one. And then here you have a really list. Let's say it's a job list of the day. with the job list of the day, you have multiple, you're cutting multiple dimensions, multiple blanks. Let's say, for example, today we're cutting 4 inches and I want 5 of them. And then plus here, and then I want 20 inch and I want 6 or 4 of them, etc. So you fill the whole cut list and you can save this. Let's say today you work in this work list, we call it job 1, and there is another cut list we call job 2, right? So for example, this job 1, I just like made it, I can save it and I call it test, for example. I check, now we save there.
So we can go back.
Exactly.
Okay.
Exactly. We can exactly go back. We can load that program or that list.
I think we had a question come in, right? What's the power requirements on this?
The power requirement is 230 volts.
230?
Yeah, 230 volts.
Okay.
It's a 3-phase machine.
3-phase.
Yeah.
Gotcha. Okay.
So here we can load the programs. So we can click on this icon here. We have, because you can see we have multiple cut lists here. For example, the last one we made test, and I can load it. So now you can see the list is there. I can load a different one. Let's say the one for today live, and we will see all the lists here. So basically you're gonna cut it. The first one, example. So actually we're gonna cut some material. So 7.5, you're gonna cut this copper here. So we're gonna push it all the way, make sure it's square, and then like I said, we have 2 options, even using the pill or I can use the button here. For me right now, I prefer use the pill because I can stay in the middle of the machine. So there it is. And you have your material dropped to the wagon.
I want to stop you there for a second. Yeah. We are cutting copper here, right?
Yes.
I know a little bit ago you were explaining the SSM.
Yeah.
And for this demonstration, you know, we really wanted to portray running the softer material, especially on the folder. But let's talk about the SSM and what the difference between the Rapido is and the option of the Rapido SSM.
Yeah. So the most optimal machine or shear for the copper or all sensitive material is the SSM machine. Why? Because right now, as you can see, guys, like we dropped the material to the front. It may be some marks, and imagine with me during production scenario, you will have multiple blanks on top of this. And it's always the second and the third one will be scratching the first blank. So in that being said, this machine is not like optimal 100% for sensitive material. The machine that is more compatible is the SSM. Why? Because it works actually like a magic trick, right? So you have your material here, and what it does, it baggage is like goes so fast that actually the material drops, and it drops to the back. So you have a table back.
Is that dropping at a diagonal motion, or is that coming down parallel? It's
coming down really parallel because what helps actually for that is the baggage moves so fast that the material drops in a parallel way.
What the material is doing is it's falling down and it's stacking on top of each other versus the Rapido. And I think that we had another question come in of, is it always jumping to the front or sometimes at the back? Yes, we can make this machine be a backdrop. For that, it is a customized machine. Most standard applications is people want drop to the front. For the rear drop only, it is going to be dependent on your shop setup as well.
Yeah.
Right?
Yes.
Another question was 14 gauge. Can this machine cut 14 gauge?
Mild steel?
Mild steel.
So we talk about maximum capacity is a 13 gauge. So yeah.
Yeah.
Yes.
Now, to that point, what I always ask my customers is how much
Exactly.
are you doing 14 gauge?
Yeah.
Because if you are doing, I like to play an 80-20 rule, 80% of the time, if you are doing the 14 gauge, you're going to want to bump up to the Evo.
Yeah.
And the Evo is 11 gauge capacity.
That's true. That's true. It's like I would say driving a car. You don't want to get a new car or truck, right? Yeah, and just like push the gas 100% all the time, right?
Yeah.
So yes, it can do it, but it depends.
Longevity.
Exactly, and also if the volume of production. If you have a volume production 14 gauge, yes, it's more optimal. It's actually more recommended to actually bump up to the next machine.
Right. So another advantage that the Rapido with the cut link is before we adapted to the cut link control itself, we did have the rotary. Let's talk about that a little bit.
Yeah.
On the rotary, number one, it takes time to adjust to find the right set of the dimension.
Yes.
Right?
Yes.
And then number two, as you explained how easy it is to put your set dimension within the cut link, it automatically does it. So it's very precise and it's very consistent. And at the end of the day, it's going to improve your throughput from staging, as I explained earlier, from going from getting your material itself, shearing it down, and then moving on to the folder. Yeah.
For that, just if you'll sorry to interrupt you, but just like to add 2 points here. We're talking about the rotary thing. Just like there is two things that I see. Maybe other people can have other comments about it. It's just like it takes time, so that increase the time of production, and like you said earlier, time is money, right? Yeah. So that's one. Second, there is an area for a human error. So whenever you do it, there's like the error factors get involved. For a CNC, especially whenever
that's a really good point.
Yeah, especially whenever you're using the cut list, right? You're here 100% here, and you're like, okay, I need 7.5, I need one of them, 5-inch, etc. And now, whenever you save it, you're reducing human factor here, right? You're reducing the error, and now you're just gonna load the program and launch it, and that's it.
Right. So I think that we had another question come in. Thank you for all the questions. And you and I were talking about this yesterday as we were getting the machine set up. What about the hold down?
Yeah.
On the material itself, especially for your aluminum, your copper, can you take that away on this machine?
So that feature is actually like on the SSM, in the SSM Rapido. So what it does, so whenever you hold your blank, right? And then the guillotine comes down, right?
And why is it holding it?
Sorry?
Why is it holding it?
For precision. So of course, like we're holding to have a really precise cut.
Okay.
Right. So whenever we're talking about 5-inch, it's 5-inch. So we're holding the blank. The way that we're holding the blank, the guillotine gonna cut like this, right? And now the cut is already finished.
Right.
Whenever it goes up, if it's still holding it, you still have a little bit of
burr.
Yeah, burr here. So in sensitive material, what we do, we activate that function, that feature. What it does, the moment the guillotine goes up, we're releasing also the blank. So we can actually we're not holding it anymore. So we can go to the zero position or home, right? Without having any burr, and it will be a clean cut.
Awesome.
Yep.
Another common question when people are purchasing and or looking at the shear itself, whether that be a Rapido or the Evo, is, they may have a 15, 20, 30-year-old shear and it's still working, still doing the job. But the squaring arm, the squaring arm is 100 inches.
Yeah.
Couple issues with that is it gets in the way, pokes you in the stomach,
Yeah.
you know. And a lot of our consumers, it's like, man, I really can't see myself going without it because I've had it for so long. I understand that change is hard. But what we've done is we have a 15-inch squaring arm on the front, and we have one on this side, on the left side, and we also have one on the right side. So let's just say that Yassine and I are working together on a job, and our parts are 5 foot.
Yeah.
Right? So what we can do is, of course, we'd have to cut our 10-foot piece in half, but you'd work on the left, I'd work on the right, I can square up, you can square up, and we still have an accurate cut.
Yeah.
So that is another advantage of the Rapido. The Rapido does come in 2 different sizes. This is a 32 and or 3.2 meters, 126 inches, or the 41, 4.1 meters, 161 inches. Get the question all the time of, man, why do you guys do 126 inches when the blanks are true 10 foot?
Yeah.
Gives them a little bit wiggle room, and they like that. I know that when we move over to the folder itself, you can kind of explain to that, but that's, you know, some common advantages of the shear itself.
I will add also like to that room, that extra room. One of the things I just thought about it right now, actually, like if you want to cut a conical part, right? Mm-hmm. So we have an option for that. And if you want to just like cut with your eye, this machine have an LED lights, right? So I can draw a line of the cut that was like tapered, conical.
Okay.
And because I can see, and you can see here, actually, like these cuts here are here for a reason. So you can see where is the cut line. And the LED lights there helps you to see the cut line. So I can actually like make this blank tapered, right? Then align it to that line, right? Even though it's 10 foot, but because a little bit of that space, I can move it in rotate it a little bit.
Get it like an angle.
Exactly.
Okay.
And then cut it.
Are there any more questions on the Rapido that's coming in? Okay, so
if not, we can just start continue the production.
Yeah.
We actually need like some blanks for our folder.
Well, before we do that, you know, some common questions that I get from my customers too is, you know, how accurate are you trying to get your measurements, right? If you are doing it, like you said, manually, and we go from a 10-inch cut to a 6-inch to a 4-inch, and we're all the time changing, how many times do you see that, you know, we're having to go in there, oh, nope, it's off by an eighth, 18th, 16th, and then we have to go and adjust. And so what that's doing is, number one, it's consuming time.
Yeah.
Number two is it is wasting material.
Exactly.
As you are, you know, troubleshooting over and over and over. So besides being this accurate, you know, it's eliminating a lot of the waste too.
Yes.
And I want to point that out.
Yeah. Yes. Also, like, I would say it's easy to be accurate one time, but to keep that accuracy, right?
Right.
We're talking about repetition. That's also like one of the advantages of the machine, that you get the same result each time, not just like the first time or just like for one, but the repeatability of the machine, of the accuracy, that's also important. Another thing you just remind me, actually, like this machine, you don't need to set up for different gauges. So for example, yes, it's 30 gauge, but it can also like do 29, it can also do 20, 18, all the ranges between between 29 to 13, you can all do it without adjusting basically anything. You don't need to adjust the gap, nothing like that. You just get the blank, you put the dimension, you hit cut, and voila.
I think another question come in. How many times, let's just say that we are in full production, 8 hours a day, 40-hour week, how often are we having to sharpen the guillotine shear?
So that depends. Actually, like it depends. It's not a fixed time. I would say, for example, 6 months to a year. If you're dealing with aluminum, for example, a lot of aluminum can maybe stuck in the
Blade itself?
in the blade.
Okay.
But that's after like, using it for like 6 or 1 year of production, of a continuous production. I just like a sample clean up of the blades, and you're good to go.
Okay.
Yeah.
So we went over the Rapido, and we've done some cuts. Kind of want to go over some advantages of the modern folder that, the safety, right?
Yeah.
Is because what I see out in the field a lot of times is high production shops are still using manual handbrakes.
Yeah.
And I go in that shop, I'm like, wow.
Yeah.
So safety, let's start there. It eliminates pinch ports.
Yeah.
I hate to see it. Unfortunately, I do see it, but there's injuries out there. Yeah. So it minimizes, will never eliminate, but it minimizes and what you'll see is the opening height.
Yeah.
So of the folder itself. And that's number one. Number two is,
sorry to interrupt you again.
No, tell me my thoughts.
The thing just remind me that we didn't talk about the safety for the chair. Just gonna go back,
Oh, I think there was another question of a dead stop.
Yeah.
Is there a kill it?
Oh yeah, yeah. We have the emergency stop here. For anything happens, you just click on it, and then everything stops. So, and then to release it, you need to turn it. That basically you're here, you know what you're doing, and you need to turn it to release it. Right now, it's released. You hit the green button again. Now it's ready, back to production. About safety, because this machine, the drop is in the front, you can see this is here we have a cage for safety. So this cage is actually like making it basically impossible to get inside there, your hand inside there. So this is really safe. For the SSM machine that have actually like drop into the back, that one have curtain lights on the back. So for safety, you have curtain lights to the back, and whenever you drop the blinds there, whenever you're gonna go to pick up the table, the machine stops because you cross the curtain, you cross the light for safety. So this one does not have any curtain lights because have a cage and the material is dropping to the front. The SSM have a curtain lights because to pick up the material, you need to go there inside.
You need access.
Exactly.
Okay. So let's go back to the folder. Number one, safety itself. Number two is one of the issue points of trained operators. The learning curve with the folder itself.
Yeah.
The controller has been simplified.
Yes, sir.
A lot of the skilled operators, are they used to doing a line by line?
Yeah.
Or are they used to doing a drawing?
A lot of them is line by line.
Right? Because that's the way that they learned when they were 16 years old, and it's hard to get them to switch.
Yeah. Yeah.
And I always challenge them to, try it out. And every time I visit, more times than others, they are still doing the line by line, and that's okay.
Yeah.
But, let's just say that we hire a 20-year-old and he has no experience.
Yeah.
Then what? So that's why we have simplified the control iPhone.
Yeah.
You give it to a 2-year-old, and 5 minutes, you're like, oh man, I didn't know I had those games.
Yeah.
And they're playing it. And you're so surprised on how they just adapt. And that's what we have strive to do on our folder, is for it to be simplistic on the control.
Yeah.
And then when you put all of those together, you're gaining time.
Oh, of course.
Right?
100%.
So let's just say that you have a new hire and 2 weeks of training and they're good to go.
Yeah.
Because they make sense. You give them a physical drawing.
Yeah.
of a coping, and it has the hems. It's 1/2 inch, and then you got 2 inches up, 4 inches across, and then you mirror it, and it's done.
Yes.
Right.
Yes.
So let's move over to the folder itself.
Today we're going to be working on the Rapido 32. I'm going to show you how to calibrate it if it is either cutting too big or too small after you do your initial cuts. First off, we're going to do a 2-inch cut and then see if it ends up being too big or too small. We'll adjust it afterwards. So we got about 1 3/4, so we're about 1/4 short. I'm going to show you how to adjust it a little bit bigger in the parameters. All right, once you're at this point, you need to go a little bit bigger. Go back to your main screen, unlock it, type in the word test, go to the cogwheel at the bottom, go to back gauge, go to number 5 out of 6. So if we're a little bit too short, we're about 1/4 inch too short, we're going to add an 1/8 to it. To add more to the piece physically, you're going to subtract from this number. So it's going to be 5.256 away from 3.81. After you put the number in, you're going to home it, let it get done doing what it's doing. Go back to your home screen, go back on the cut, put it back in your 2 inches. You're going to do another cut. And that put us right at 2 inches.
So Yassine's getting ready to cut the blank needed for. We're going to be doing a drip edge with the copper.
So, sorry for that. I had to cut some blanks to fold it. Here we have the FS32 XSPACE 14 gauge capacity metal cell with our new software, Neuralink.
So let's talk a little bit about the machine itself, then we'll dive in on the part itself.
Yeah.
Okay. The back gauge.
Yeah.
What comes standard on this?
So,
because I know that there's a 40-inch back gauge, and then there's a 60-inch. Let's kind of talk about the differences of what comes with this machine, and then what the option is to upgrade if you want the X-tape or the conical.
Yeah, so the standard back gauge that came with this machine is the 40-inch basic. We call it basic back gauge. So with this one, you get basically really good space, especially if you're dealing with architectural parts in general. We do,
and that is a good point, because maybe W Valley is one of the widest parts for architectural world.
Yeah.
Or the very large cornices where there's a lot of bends, a lot of the radius in it.
Yeah.
But even at the 40-inch, it does give you a lot of space to utilize, and if need be, you can even work on the front side of the machine too.
Yeah, that's true. The option one is what we call the flexible back gauge, is the 61-inch. That one actually, why we call it flexible, one of the things is to give you that to make conical parts. I would say conical parts, or
tapering.
Taper parts.
And what's that made for? So we have, not so much for the operator, but it's for the guys out in the field that's installing.
Yeah.
They love it, especially for what? Gutters.
The gutters, yeah.
And it's very minimal. It's about 5 millimeters per 1 meter.
Yeah,
and it's only made to male to female parting together, so they slide nicely together. You ever tried to fit a straw, the same size straw together? It's kind of hard.
Yeah,
it can work, but
yes.
So yeah, and then a couple other features on this is when you're going from 18 gauge to back to 24 gauge is we have our material thickness adjustment.
So you can adjust it, adjust to different range of the gauges that you have. So basically, you're dropping the folding beam to accommodate the thickness of your material. It's a good use, right?
It's a what? Sorry.
It's there to use it basically. It's there like to accommodate different gauges and different thicknesses that the customer will use to make its part, right? A lot of our customers prefer sometimes you just like drop it to the maximum and do a material table to accommodate the whole range of thicknesses. So if you prefer to do it that way, to drop it to the maximum possible, and then you basically bend all the range of thicknesses with that. That's good. You just need to do multiple material tables for each material, or you drop it for each thicknesses, and that's, I would say, much more accurate.
Okay.
Right. That's being said, another advantage of this machine is it's on the name, it's XSPACE. So the geometry of the folding tool here, this space here, this will change the time on your production. Also, like, change the time. Why I say that? Because, for example, a part that you need to flip it 2 to 3 times, now you're flipping it just once. Why? Because you have more clearance here,
more free space for
more
the
free
operator.
space. Yeah, exactly. And
now, what's the maximum angle that you can get with the XSPACE itself?
So this one here, I can go to 135.
Okay.
Yeah. So 135. That's really a common angle.
Okay.
Another thing I want to talk about here, we're still talking about the folding tool, is this ball screws here. That's so
the bayonet style.
Yeah, this is like makes this so easy to remove or to install, because what you do is just like you loosen up and you take off this one here, this screw here at the ends, this one and that one at the ends, right?
The far ends,
and then you loosen up all this.
But
then
you don't have to take them all the way out, right?
No.
Okay.
No, just loosen them a little bit. Then you push the folding beam. Sorry, the folding
you can
tool.
see how the bolt, and this is wider, so you can just easily slide it over.
Yeah.
And then
so you can just like
this
take
machine comes with a 25 millimeter toolbar and then a 10 millimeter as well.
Yes, that's true. So you just like you said, just like push it, take it out, and then bring the other tool, put it in, push it this way, and then you put the back screws and you tighten up the whole screws.
Okay.
Talking about that, we're still here. Let's talk about crowning. So for crowning, you don't need to guess generally. This is here that you can deal with the percentage, right? So here, what you need to do is like, you just loosen up for your knees. You can also like jog the folding beam to 90 degrees first. Then you loosen up all these screws except the one on the ends. So you loosen up all this, right? Then
why is that easier?
It's so easy because first it's there. So now you don't need to use shims, and you don't need to be like, okay, I need to put this thickness of shim or 2 of them or 3 of them. Now you have actually like a number, a percentage, right? So
I think another question came in.
Yeah.
And being out in the field, we do get this question a lot. So thank you for asking it. Is how often do we have to adjust the crowning?
So it depends on the material. It depends on the material.
It's a variable.
It's variable.
Right?
It's
variable.
variable.
And why is it a variable? Because if I'm running, let's just say 5 different architectural parts. Okay. And is each part going to need to be crowned and or adjusted? So
the crowning is related to 2 things.
Okay.
I would say the material, right? And how long is your part? If it's a small part, you don't need to play with the crowning. You don't need crowning.
Why so?
because the material or the part is so small, so it will not deflect. Whenever what we're doing with crowning is we're trying to fix a natural deflection happens whenever you have a long part.
Okay.
So whenever anything, if it's long, a truck, back to the truck, for example, you can see that it's curved a little bit, right?
Okay.
That's why, because whenever you put the weight, right, so now it's flat. So having the part having that deflection is a natural thing happening. So to compensate that deflection to work,
That's a key word.
yeah, to compensate that deflection, we need the crowning, right?
Okay.
So whenever it's so small, you don't need it. There is no deflection.
Now,
whenever it's long, you need it. So that's number one. That's the variable number one. That means the length of your part.
Okay.
Second one is the material. So some material depends on the tensile strength, right? So some material needs to have more crowning. Some material needs just a little bit, a touch. So
now,
it depends.
Would you say heavier material
Yeah.
needs more crowning?
Yes.
Okay.
Yeah. Yes. I would say heavier and or strong material. Whenever harder material. Whenever I say strong, sorry, I'm talking about the tensile strength.
Okay.
So this is.
And that makes another good point. Is let's talk about the nose bar.
Yeah.
On this material, because as we were getting material earlier. Sorry, I accidentally grabbed 80 grade.
Yeah.
And you're like, nah, that's not it.
Yeah.
But 80 grade truly isn't 80 grade anymore, is it?
No.
I mean, not to say that it is a set standard or what I'm saying is 100% accurate, but what we look at when we are asking, the production manager or the owner, whomever we're talking to on their application, is what kind of material are you working with?
Yes.
Because it is super important.
Yes.
Right? On this one, we do have the 1.0 or the 1 millimeter nose bar, and that's used for what kind of material?
1 millimeter is used for mild steel, like 55 KSA. So this is actually our reference.
More of the 50 grade.
Yeah, the 50 grade.
Right?
Yes.
And let's just say that I'm talking to a customer and he's
80.
And he's using 80 grade. What do we recommend on 80 grade?
1.5 and then to 2 millimeters.
Okay. Now explain that to me of why we need to, what the nose bar looks like.
Yeah.
And the reasoning why.
So I think I'm going to use the whiteboard for that one.
Okay.
So here, sorry, I'm cleaning your. So here, this is the tool, all right? Whenever we're talking about the nose of the tool, we're talking about the radius here. So let's say, for example, that one that we have shape like this, and then if I zoom in, it's actually a radius, and that radius is 1 millimeter, right? So this is what we have here. Whenever you're dealing with material that is not that hard, right? You will have also like more. We talk about ductility here, but let's just focus about the how it's going to be a lunge or the elasticity of that material. Stretched. Okay. Yeah. So we're talking about the elasticity of the material. We're talking about how it's going to be stretched. Whenever we have a small radius or a sharp one, because we do have some tools that we call it R0. It's really sharp. There is no radius in it, right? With this one, you need material to be really elastic. Whenever you have the material is really, really strong, you cannot. Whenever you try to stretch it does not stretch that much, right?
And what happens to the paint?
The paint, you really like get crease in the paint. The paint gets, so all that happens because the material is resisting the folding.
And it's brittle.
Yes.
Right? So the paint wants to go as far away from the material itself And that's why we do always ask when consulting with the customers, hey, what kind of material are you using? And to recommend or get them in the right fit of, you know, not necessarily the machine itself, but what kind of tooling itself.
Exactly. Also, not just the nose radius is also one of the major factor that plays a major role here to not have an increase the bend, etc. But we can also talk about the speed. Sometimes you will need, if you're dealing with this kind of material, you will need to reduce the speed to give time to the material to be in that plastic zone. So whenever we're folding material, right, there is two zones, two major zones. There is the elastic zone and there is the plastic zone. You need to get it from the elastic zone to the plastic zone. And what I'm saying in simple words, you need to give time to the material to take the shape that you want it to have.
That makes sense. So we went over some of the features of the machine. Let's go over some of the controls.
Yeah. Before that, this is the FS32. Just like to mention other product that we have. We do have an FX32. We do have an FS without XSPACE. So it depends, like I said.
That's the F32.
Yes, FS30, F30, sorry, without XSPACE. And then we have the FX32 with or without XSPACE. So for that, like we talked about earlier, we give you the machine, or we sell you the machine the most optimal to your applications.
Right.
It depends on the application.
Right. And the difference between the FS and the FX is the FX is the exact same machine.
Yeah.
But it does have the rotating head with the combi.
Yeah.
And that allows for the operator to make four-sided parts, chimney caps, box and pan, whatever you need. And then also to the FX comes standard with a 60 amp back gauge, allowing you to make tapered parts.
Yeah. All right. So we talked about the folding tool, the crowning, material thickness adjustment. Now let's talk about the program or the control. So here, before talking about the screen, I want to mention this, that actually the screen comes with I just took it off, but this is like a screen protector for the screen. You know, whenever you're folding your part, there's a risk that you're gonna touch the screen. So that is one really important element. So for here, you have the new link, our new software. Let's actually log out and talk about from scratch. This is Neuralink, so this is our new HMI software. One of the first things that I want to talk about, that multi-users. So with Neuralink, you can have multiple users. Let's say there is operator A, operator B, C, etc. So it depends how many shifts you have. And for each operator, you can configure the software to be in metric, for example, if you want, or to be in Spanish or a different language than operator C. So you can do that. And each operator can have, or each user can have multiple rules. For example, one of the rules can be like the maintenance. If in the shop you have the maintenance guy, and maintenance guy that you wanted to be the only person who can calibrate the machine, for example, right?
Yeah.
So you can create the user with a specific role. The operator, for example, you don't want him to be calibrating the machine or deleting a profile or anything like that. So you can exactly specify for each individual or each user what can and cannot do. That being said, you log in here, for example, operator. Then you put the password, and then you hit log in. So whenever you log in, it opens the last thing I was working on. But normally, if it's the first time, it will open to this page here, is actually the profile database. So this here have all the folders that you can create. And you can also like have subfolders. So you can have a folder and you can have subfolder. You can organize your production. For example, let's say you want to have the job list of the day, and you can name it job list of the day, and you can put all the profiles that you are doing that specific day. Or you want to organize it by customer. So we have customer A, customer B, customer C, and each customer inside there, that folder, you can put all the parts that he ordered. So it depends on each one how he wants or she wants to organize the production, right? But this gives you that capacity or that feasibility of doing it. Means like you create folders, subfolders, and you can move programs. For example, here I can actually like highlight this program here and move it to a different folder. I hit save. Now I just move it to this new folder. So you can move folder. You can name it. Change the name, for example, of this program. I can take the MS, for example, I hit save. Here's just rename it. So basically,
job organization, it looks like, right?
Yeah, and it's so intuitive. Most everybody works with their laptop now, with their PC. So whenever you create a new folder, you name it, you copy it, you move it to a different place. It's exactly the same concept.
Okay.
So whenever you just open the software, you get that first, intuitive way to work, basically. So, of course, one of the most important thing in any machine, in any folder, is the material table. So you want, of course, we can talk about this just in a few also in details, but we do, our technicians, whenever they install the machine properly, and then they move to the next step. The next step is creating the material table optimized to the specific to the customer and what he's doing.
Okay.
And then also not just make not just fishing the fish, but teaching how to fish. It's like not just making the material table, but also like teaching the customer how to make the material table.
Okay.
So that will be my next thing to talk about. So if you click on the material here, the machine comes with 3 raw materials. Comes with mild steel, aluminum, and copper. So aluminum and mild steel and stainless. Sorry, I said copper. It's aluminum, mild steel, and stainless. So this is the 3 standard raw material that the machine comes with. And each raw material have a spring bag, have a less of spring bag. To simplify that, let's talk about that in, for example, mild steel here, in the folder mild steel, I can create a material table so easily by just like putting the thickness that I have here, how wide or the width of my part, let's say it's 120 inch, right? This here, the folding tool, which one I'm gonna use, it depends which thickness I'm using. So the maximum, for example, this is a 14 gauge. If I'm using 14 gauge, for example, I need to use the 25 millimeter, the widest tool.
Why would you use the bigger one for the thicker gauge?
It's the tool, the strength of the tool, of the material, will oblige you, will make you use the bigger tool. The bigger tool is stronger.
Oh, okay.
So the bigger tool is stronger than the small tool, right? But why? Another question that I get a lot from customers actually is like, okay, so why not just like put the strongest tool and just leave it there and use it all the time? All the time. Mm-hmm. You can do that. It depends on your application. But there is some parts, especially whenever you have a Z shape, for example, right? That offset, you need the tool to be in that offset. In that way, that being said, you need a smaller tool.
Right.
So this is one of the reasons. But if your application or your part that you're making does not need this, of course, use the bigger tool.
Okay.
So here, then you choose, like I said, the tool, hit save, and automatically Neolink create a material table for you. This, you can settle with this angle correction and length correction and all this values, you can say with this and use them. This is a really good starting point.
Okay.
But sometimes you want it to refine it more, right? To refine it more to your specific material.
Right.
That comes what we call the bend assistance. So, for example, you're going to refine your 90s, right? So you can highlight this one, and you click on the rule here, right? Click on that rule, and then you bring a piece of that material that you want to make the material table for. And you say, okay, the unfolded length of it is 6 inches, right? Now, what you do, you hit next, you bend. Whenever you are in this, you can actually like move the machine. So we're not even like out of the material tab. We're still in the material tab, and we're just like refining that bend. So here I can control, like I said, the machine. So basically I can bend, right? I can bend it, and now I can get my L shape, measure the angle, measure the dimensions, hit next here, measure everything, put the angle, for example, let's say I did not get a 90, I got 88, right? Now, and it was 6, so I put 3 and 3 here, right? And now I hit save. You can see now that table, right? You can see the table here that changed the angle correction for me.
It corrected it for you.
It corrected for me. Yeah, and now you can just need to save it and use this material table, and you will get your true 90s now, right? So you do this. This is important phase.
setup.
Exactly. You do this for I would say the first couple of days, like 2 or 3 days, depends on how much material you have. After you do this, you save it once, and basically you never touch it, except if you change the supplier or the quality of the material changed. But if you have the same material, the same supplier, you get basically the same results each time.
Okay.
So that's we talked about the material, right? One thing I just to talk about a smart material. In U-Link, you do what? You basically create the material table for a specific length, right? And the software or U-Link will, for example, you do it for 120. Now, that material table will be used from 104.25 inch to 120. All this range will be using this material table that is for 120. And you don't need to go back to the material table to choose it. Now, U-Link choose it for you. You just need to choose which material raw you're talking about. Is it mild steel? Is it stainless or aluminum? And you need to choose which thickness you're talking about.
Okay.
And it will go automatically to that thickness, even though there is, you see here, for example, for this mild steel, for this specific thickness, you have 2 material tables. The U-Link will pick up the most optimal material table for that specific part.
Okay.
That was material, right? Let's talk so quickly about the drawing mode. Okay. So, or let's do the old way
Old
first.
style.
Yeah, the old style first, line by line.
Okay.
So in the line by line, you can. This is the interface first.
I
You
don't
can
really
add,
like how the new Link is graphical images. You know, we've adapted from ProLink to New Link now.
Yeah.
And what I really like about the change is it's better graphics, so I don't have to read it. I kind of automatically know what it's showing here.
Yeah.
Right. So I think that's cool.
Oh yes, it is. You can see just the samples before like the words, or before like having a training. Just like look into the samples, you already make sense, and you know what
it stands for.
What it stands for.
Yeah.
So here in line by line. So first, what you need to do is like, are you adding what I call normal bend, like 10 degrees, 90 degrees, 45, 70, or are you making a hem, open hem, closed one, a teardrop, or are you making a radius? So here you can choose first. Let's say, for example, you want to make it just a 90, so you click on here, and here the line just been added. In line by line, yes, it's the old ways, but also it's you or the user or the person who's programming that get 100% responsibility. Means like you're telling the machine what to do and the machine will do it.
To exact.
To exact.
Yes.
In the drawing mode, you're splitting this responsibility between the machine and you. So the machine will tell you, okay, I will take care of this part, you take care of this part. In line by line, it's just like the programmer. So here you put the angle, the folding angle that you want. Next, you put the bag gauge, right? You want to send your bag gauge to 10 inch. So you put here 10 inch, you hit check. The clamping pressure, is it 1%? Is it 100%? The opening height, the speed, the thickness of the material adjustment.
Speed, is that the speed of the machine? Is it the speed of
the speed of the speed of the folding beam? The speed of the folding
Now,
beam.
why would that be adjusted?
Like we said earlier, it depends on two variables. It depends on the thickness of the material or the strength of the material, the tensile. Whenever we have a strong material, we need to move a little bit slower to give it that time to be folded.
Okay. And another thing that comes to mind is, a W valley.
Yes.
And we have a lot of that material that's sticking out.
Yes.
Of the clamping beam, right? And that material is flopping everywhere. And so instead of running that at 120 or 100%, maybe let's slow that down to 15%.
Yeah,
right?
That's true. That's true. And you can run panels also on this machine, and you need to slow down. That's true.
So let's look at the
drawing mode.
The drawing mode.
Yeah, that's okay. In the drawing mode, whenever you're here, first thing to do, also in line by line, is to pick up the material, right? So you hit the raw material, you pick up the material that you're going to be dealing with, and then you put out the thickness that's in there. Then you hit save. Now you just start to draw. How? Touch the screen. It's so intuitive. So you touch the screen and then you hold it and then you drag. This is the way that you can basically draw your part. It's so easy. It's so intuitive. And as you can see. So let's start again.
Let's just throw something simple, maybe
U-shape.
U-shape.
Yeah.
Or let's do a ridge vent. A ridge vent. And let's show how we can only draw half of it, and then let's mirror the other side.
Yeah. So I will let you do this one. So now, whenever you draw that, you can just like click on this, and then you choose which side you want it. Do you want it to be mirrored on the blue side or the orange side? The orange side, you hit check. Now it's mirrored.
And another cool thing about the new ink is, let's just say that I want hems on this.
Yeah.
On the Pro Ink, we had to start on the left side or the right side.
Yes.
And we couldn't go back and edit those changes, right?
Yeah.
So what's really, really cool on here is I just tap here and I put a hem. I can click here. I can put my dimensions.
Yeah. This is what we call...
Click on the other side. And now, boom, I have a finished product. And then I have my little squares in here on my angles. And then also two of my set dimensions that needs to be there. If 3.5 isn't correct and I want 4, I can easily put that in.
Yeah, I want to add also like just here what we call flower. So whenever here you click on this, you get this flower shape that there is a hem in it, there's a normal flange, and there's a radius. Another way to make actually, like if I go back if I go back here, and another way to make a hem is actually like just click on it, and then you go back 180, and then and here you just made another ham. So there's a different way to make it. There's a different way to make the ham. Another thing, we just showed the mirror function on this one. One thing it can show is the whenever you want to duplicate, right? Let's correct this to 90. You can always work on this side. That means like just draw the shape, and then you can come back to this side and do your dimensions, right? So here they say I'm gonna do to repeat this one from this side. I can choose which side. I can duplicate it. Let's say here, and I can duplicate this shape.
Wow.
So now I have a panel, right? I can also choose which side I have the pent. If I have the pent inside here or outside.
I really like that.
Yeah. But let's turn this to 3D, and now the magic happens. So you can actually see the part.
A finished product.
Yeah, as a finished product. You can take a picture of it, say to your customer, and be like, "Hey, this is
doable.
This is doable."
Okay. Now let's go back here to our database. Let's go. I'll let you do it because you saved the programs in.
Yeah.
Let's go ahead and run some parts, and then I'd like to illustrate on the sequencing, on how easy it is on the new link, and how we can, there's a few different options or ways to do so.
Yeah.
But then also, user friendly. But then from the guys that are going from a Pro link to a new link, it is a little bit different.
Yes, it's this one have a more modern touch to it, the color scheme and the process, the workflow of the process. So first, whenever you are in the draw mode, there is 3 pages. There's first page is where you draw your profile. Next
Can we go
page,
back to the drip edge that we're going to make for the copper?
Yeah. So we go to the cylinder. It's this one.
Okay.
All right. So this one here is the drawing. So whenever you finish it, right? You select the proper material table by selecting the raw material and the thickness and the width, and New Link automatically will pick up the material table for you. Then after you finish this, you hit the next page. Next is where you're gonna prepare the program. You're gonna do the sequencing if you need, change the sequence if you have to. The software actually will suggest sequencing for you, and you might want to fine tune that sequencing or add some angle correction for that specific part, or there's any baggage compensation that you need to do, reducing speed. All those settings and parameters are in this page.
Okay.
And by the way, you can always hit play and simulate the part, right? In 2D, more actually like you can see the whole machine, right, making the part in 3D.
The good thing about this, of the illustration, is, you're working on your sequencing and can't, let's just say that New Link automatically puts the sequencing together for you.
Yeah.
And you're like, nah, I think that I know of a better way.
Yeah.
And then you put 3 to 2, and then it's like, oh no, now I collide. Mm-hmm. It's actually really cool that it's illustrated here.
Yes.
And then so you can make those corrections after you've already edited it from its original file.
That's true. So basically, like this simulation, like it's not just like you just need to see it. The machine or the software give you an alarm if there is any collision. It will give you a yellow triangle here on the top that tells you, oh, there is a collision. You cannot make it.
Okay.
And then you change the sequence, and then that sample goes away.
Okay.
Let me just verify the sequence in here first last time, and we're just gonna run one part to see how it goes. So whenever you're good with here, you go to the next page. The third page here is actually when you're gonna run it, and here you put the quantity if you're gonna run, and you select, are you counting up or counting down? Then you hit start, The moment you hit start, it's hit the lift pedal to start the program. And now we're gonna pick material. We'll put some gloves on.
I think the stretch out I had is 7.5.
Oh yeah,
Correct?
7.5. Yes. I think
a question came in, and it was, he has a different program. I'm guessing possibly he has. That's not 7.5.
no, what's that?
It's not 7.5.
Oh, so what's that?
Just over 9.5.
Okay.
I think this one might be. This one is.
All right.
That one's 7.5. Sorry about that. You might have the old Pro Link,
Yeah.
and let me move this out of your way.
No, you're good. Just gonna pick it up from here.
We did get word that you will be able to upgrade to the new Link. We don't have a timeline on that just yet. As soon as we do get that, reach out to your rep or the service team, and we'll get that answer for you.
So I just turned the screen because I want to show you also like that it shows you the orientation of how you're going to be handling your part. So here, just put our blank.
Before you start making parts, can you explain, and I like this illustration too, our pedal has 3 different pedals.
Yes.
Can you explain which one represents?
Yeah, so the first one here is actually like to clamp the blank, so it moves the upper beam, moves it down, right? If you push harder, that's for safety, it goes up. The second one is actually after you clamp your blank, you can fold it with the second one. If you push it also, it will unwind itself. Again, if it's for safety. And the third one is for bringing this upper beam up.
Okay.
Yeah.
Thanks for explaining that.
Yeah. So whenever you're gonna notice one thing, that whenever you're going down, it will stop, right? So it will stop here for what we call a safety stop. So here, basically for safety to protect your fingers.
And it's just enough, if we come a little bit closer to illustrate this, you know, if my fingers were in here, it's going to pinch, but it's not all the way going to cut the finger off.
Yeah, it's going to hurt, but at least you still have your finger.
Of course, depending on how big your finger is. But, of course, our machines these machines, the CIDAN brands, are made in Sweden.
Yeah.
And they do come to the States already OSHA approved, everything like that. There are additional safety features.
Yes.
One of which is the bumper guard for the folding beam.
Yeah.
As it's coming up, if you nudge it with your knee, it'll automatically stop the clamping beam, right? And then the second one is the safety laser light.
Yeah.
And that is within the fins here.
Yeah.
Now, what that does, okay, the machine itself will be fully automatic.
Yes, sir.
Okay, and it will be running as normal. What the safety light does is, as the clamping beam is coming down on a down motion, and that is interrupted, that's going to stop the clamping beam itself. Other than that, once it's made it past all the way clamped down and you collide with that laser beam, because you're in a safe mode, operator's free to make that part.
Yes.
Right?
Yes.
Okay, I just wanted to cover that.
Yeah. Also, like whenever it's on the safety stop, you can basically like get into that light curtain and the machine will not stop because you are already on the safety stop.
Okay. All right. Let's make some parts.
Yeah. It is. So here, by the way, this is just remind me to talk about one of the really nice features Thanks to Ron. we have a groove here, right? You can see actually you can see here the groove.
I'm gonna raise it all the way up for you.
All right. It's up. It's up.
Okay.
So this is, you have a groove here, right? You can also see in the screen. If you see in the screen here, oh, you can also like zoom in a little bit to see this. So whenever we're dealing with the material, whenever we're dealing with hems and we want to close the hem, you know, that shape, whenever you do 146 of the pre-bend hem, the most strong area of the material is this. So instead of fighting to close here, what we do is like this relief here, this slot here, this groove here will be given clearance to the material here.
If we shut right here at an angle, you can see this groove, and what that does, it's relieving its stress as that clamping beam is coming down.
Yeah, that's exactly what it does.
Pressure wants to go somewhere.
Yeah.
Right.
So yeah, this is the strongest. Like I said, this is the strongest area of the part, and because we have that clearance here, whenever we clamp on top of it, that will relieve that stress, and now we're clamping on this side.
Okay.
So instead of fighting the ham here.
Okay.
So that's what I'm doing right now, actually. So here we're gonna clamp, and now you see in the screen, it tells me like that I need to turn the part. So here it is, and this is because it's copper. I don't want to normally.
Can I help you out?
Yeah, that would be great.
Alrighty.
And now let's put in. There we go. Oh, sorry. So I think so on number 2. So what happened here is I put in I did not see the screen, so I didn't put in the right direction. So normally it's like this, right? It needs to go like this.
So we made the part wrong.
Yes.
Yeah. That's okay. Let's cut another one.
Yeah. That can happen whenever you are in life.
Okay.
7.5.
7.5 is a stretch out.
Yeah.
And another thing too, as probably Yassine was not paying attention to the graphics itself, but that is one thing that is very well illustrated on the control, is it's telling the operator, hey, use the left pedal to clamp down. When it's folding, use the middle pedal to fold. If the profile needs to be flipped, helicoptered, again, that's going to show it on the control. Another feature here, you have a paint roller, and that's going to tell the operator, hey, this needs to be paint up, paint down. And so these controls are really making it dummy proof, if you will. I think we had a question earlier too on crowning adjustment. How is that done? The machine itself, I'm looking around. I think I set it to the side, but the machine, both the Rapido and the folder, comes with a toolkit. The crowning tool has 2 little prongs here. It's inset here. Goes all the way in, right? And then what this is doing, I'm not going to adjust it because Yassine has the machine dialed in, but as I rotate this clockwise, it's going to shim up, and it's going to Shannon's going to go down to raise or lower the heat. Give me 1 second. I got the material wagon for you.
All right, thank you.
This piece here. Another feature on the Rapido is, get this out of the way for you.
Yep.
Is your support arm for your material if you got a 10-foot piece.
All right, sorry.
If we got a 10-foot piece, the that support arm allows you to have that full piece to retract out, so you don't need a second operator to help you out as you have that full sheet.
All right.
Good to go.
Yes, sir. Oh, sorry.
Making the hem. Give you a hand here.
Yes. Now we're gonna clamp.
What part are we making here?
We're making a teardrop. Sorry, we're making a drip edge.
A drip edge?
Yes.
Okay.
So if you come here, Tony. So here we will see the effect of the next one, not actually like this one, but the next one we will see the effect of having a XSPACE. Yeah, not this one, the next bend. So here, if you come to this side, I'm sorry. Yeah. All right. There we go.
The drip edge?
Yeah, the drip edge. All right. So let's make another one.
Make it coping?
Yeah. See here for the material. The tape, please.
Tape measure. I'm gonna look to see what the stretch out on that is. $12 inches.
All right. Sorry?
We're gonna need to
No, we don't.
no?
Yeah, no.
Okay.
If you wanna like come here, and you can see. Oh, we will need the support. So yeah, so here we're just gonna put the pneumatic. Earlier I took it off, so to see the support gonna go up.
So now the support support arm, all right, on the bottom side.
Yes.
Okay.
Yes. So here we go. We have and now, sorry, we have our blank.
Get the tape measure for you.
Let's leave it here.
Oh. 12 inches. And let's go ahead and make the coping.
All right, thank you.
I can do it.
Are you good?
Yep.
Can you press the next and then hit start for me? All right.
Attaboy.
All right.
What did you tell me earlier? You used to making 4-foot parts, not 10, right?
Yeah.
Getting a workout into it.
Yeah. One of the things I really want to showcase in this part is that two things. What I did here a little bit different. I will raise this so I can see it. You can see that the fingers are dropped, right? That's a really good feature to pose the baggage, pose the finger. That means like right now, I can turn this sheet and use actually my baggage, right?
At the table.
As a table. So I don't have any fingers there, so I can turn it however I want. Right? Now I will press the pedal once. Now the fingers are popped up, so I can continue and engage against them. There it is. Another open hand. Now we're gonna do the 90. Second 90. Now I'm not gonna be flipping the part, right? I'm just gonna roll it down or drop it down to make this bend. I wanna talk about this one here. The second, what just happened here is I just clamped on an open hand. So this is really one of the really cool features, really interesting features that our machines have. Almost all our CIDAN folders, especially the FS32 XSPACE that we have,
right?
the F series. Yeah. We can clamp on top of an open ham, what we call a sim clamp. So now that was an open ham. I clamp on top of it to do a kick of a 45.
Now let's stop. Well, let's stop on the next one.
Yeah.
How it illustrates that. So let's take a close look at this. So as he clamped down to make this bend here, but at the same time, as it folded up, he's not closing this open hand.
Exactly. Like we're clamping on top of an open hand.
Right.
Yeah. Now this is actually the only true turn because of that, because of having a sim clamp.
And you just rolled the first time.
Yeah.
And then now
This is the last bend that will be just like turning. This is like the only true actually rotation that I did.
Okay.
Because we have that sim clamp feature.
Now let's stop right there.
Yeah.
Take the video over here. And you can see that there's a little bit of space here as that hem is within the machine, and as the clamping beam is coming down, it's not crushing it. And then we're going to go ahead and just be careful.
So
it's going to rotate up to make the final angle.
exactly. So here it is. You can see like a really sharp 90s with open ham that's still open even though we clamped on top of it. We did the 45 kicks and there it is. A really nice coffin.
Cool. Let's make another one.
Yeah. Yeah, let's do
the hat channel.
okay.
And what that's going to illustrate is the use for the XSPACE itself. If you look at the drawing, we have 1 inch by 1 inch, 1 inch, 1 inch, and 1 inch. And the XSPACE feature is going to allow to make that part. You're seeing that stretch out is 5 inches.
Sorry?
I said the stretch out on that is 5 inches.
All right. 5 inch.
We have that left?
Yeah, this is
Perfect.
yeah. This is not 5 inch, so we'll have to cut it.
We have to trim it down a little bit.
Yeah.
And we have the squaring arm over there. We're going to square up. Good.
All right. Yeah. That's okay. So this is the part. Okay. Yeah. I think I needed another quarter. So the part gonna say here we're just trimming it. All right, clear? There we go.
Help you out here?
Yeah, but thank you.
Yep. So again, it is illustrated that paints up on this part. It's a simple part.
Yeah. It's a simple part, but why we're bending it just like to show, even though it's so simple, right? Just a hat, but you will see in a moment. Not this bend actually, but the last bend. This is the bend that makes it with a few flips, and because we have the XSPACE, it makes it feasible.
It allows that profile to fit within the
Yeah.
XSPACE itself.
Exactly.
Now,
So
a
here,
lot of, which on the F comes standard with a 90-degree tool. So let's go ahead and make that, and I'll
Yeah.
explain the tool itself.
and now here it is. So you can see the part. Yeah.
Good. Have any more questions coming in?
Do we have any questions?
No? So hope you guys enjoyed what you guys saw today, from going from, the full shear to the folder itself, of creating a proper workflow to gain efficiency, quality of parts, and then the streamlined process of going from the shear to the folder. When working together,
Yeah.
they improve your overall throughput.
Yes.
And with that, you gain time.
Yeah.
Times money.
Yes.
And that's what really, really sets apart your average shops to profitable shops overall. And, you know, through going through I put something on the screen here for you guys, is an ROI.
Yeah.
And what I did was I took just basic numbers of 260 days in a normal calendar, work days per year. And let's just say that we're making 200 profiles.
Yeah.
And we are trying to gain through the work efficiency that we've illustrated today, to gain a 15% gain of time and or money or profiles in themselves over a full annual year, right? And so if you take those numbers and you times them together, or another way of looking at is taking the number of days times your profile to a numerical amount of $28,000.
Yeah.
Again, going back to cost of machines, that's a lot of money.
Indeed.
And if we could recap that for a full year of eliminating the touch points of the parts, taking the profiles from staging them properly and eliminating, again, the touch parts from going from stage to stage to stage,
Yeah.
it really maximizes that throughput.
Yes.
Right. And so that's what I really, really want to illustrate to you guys today of our illustration and our joining live of a full demo.
Yeah.
And this is real time, you know,
Yes.
as Tony put on the social media. None of this is scripted. So
Yeah.
I appreciate your time today.
Yes,
and
sir.
thanks for helping me out.
Yeah.
If there's not any more questions, do we have any more questions going live? Okay. Again, we truly appreciate you guys joining us today. And at the end of this video, or going live, there will be the sales manager's point of contact email on there. If you don't know who they are already, please connect with us. We'd love to show you what we're capable of, get you in the right fit, and help you out.
Yeah.
Partners together.
I would also like add, you're always like welcome to come here and visit us on site, and we can always like have demos live here with you, one-on-one, and just like you move the machine, cut the blanks, and just like make the parts, and you can see the capability of our machines.
Yeah, and then to another point of that is, you know, if your time is tied up and we just want to see within our application, hey, is this doable on your machine? It will be either going to this guy or Ron and to see if it is even capable of doing so.
Yes.
And then you guys are pretty quick of getting back to us, and we truly appreciate that.
Thank you.
But you know, that is another option.
Yeah.
So Yassine,
Yes, sir.
appreciate you today.
Yes, sir.
Thank you guys for joining us.
Thank you.
Sure, it'll be happening again.
Yeah.
You guys have a great day.
See you.